All right, today we're starting chapter 7. For some reason, the notes for 7.1 and 7.2 are together in one section, but we're only doing 7.1 today. What we're going to be studying in chapter 7 is roots of different types and what types of exponents give us roots. So we're going to begin with some rules here that I'll briefly go over, but then they'll make more sense in the context of problems. So the first one says if n is odd, then we have one real nth root. If we're taking an odd type of root, so like a cube root, a fifth root, a seventh root, there's only one answer to that type of question. If we have an even type of root, like a square root, or a fourth root, or a sixth root, then we get two answers as long as what we are taking the root of is a positive number. Because remember, we can't take like a square root of a negative number. That's how we get imaginaries. So that's what this is saying, is if we are taking an even root, like a square root, of a positive number, we get two answers. We get the plus and minus. If we're taking any type of root of 0, we're just going to get 0. Okay? And then if we're taking an even root of a negative number, like a square root of a negative number, there's no real answers to that because that's where imaginaries come from. This is our big rule for today. Looks pretty overwhelming in formula form with lots of letters. The key to it is that we're going to be studying exponents that are fractions. So instead of just having like a squared, we're going to have a to a fraction. In words, what this means is that the top of that power is going to be the power. The bottom of that power is going to be a type of root. Okay, so when your exponent is a fraction, the top of that fraction tells you the power, the bottom of that fraction tells you the root.
So,
okay.
No.
The top is the power, the bottom is the root. The second one here has a negative in front of that exponent, and we had a rule about negative exponents that we learned a while ago back in chapter 6, and that was that a negative exponent goes to the bottom of a fraction, and so that happens even if it's a fraction exponent as well, that the whole thing will just go to the bottom of the problem. Okay? So to simplify these, you could just type these into your calculator. Sometimes you'll get a nice answer, sometimes you get an ugly decimal, but I'm going to encourage you to not plug them in your calculator unless it specifically says to estimate or approximate on a calculator. The reason why I'm going to encourage you to actually try to follow the rules and do this by hand is because tomorrow I'm going to take away the numbers and put letters in there. And if you don't know how to do it, you can't type letters into the calculator. So we're going to practice here with numbers, and then you could theoretically check your answers on your calculator and know that you're doing it right. But if you're just relying on your calculator, then you're not learning the skill that will be necessary for tomorrow. So we have a fraction exponent here. Our rule is that the top is a power, and the bottom is the type of root. So this is a square root of 9 cubed. Now technically you don't have to put that little 2 there, because if we see a root symbol without any number, we assume it's a square root. I just like to put it there because then it helps students. If I didn't put a 2 anywhere in this problem, they'd ask me where the 2 went. Okay, so I still label it as being a square root, just so that we can see what happened with that 2. The top becomes the power, the bottom becomes the type of root. Then we can evaluate these in either order. We could do the power first and do 9 cubed, but I don't know what that is. I don't know what 9 times 9 times 9 is. Or we could do the root first. I like to do the roots first because that makes numbers smaller and more manageable. So what is the square root of 9? 3. And then I haven't done the power yet. 3 cubed, 3 times 3 times 3 is 27. Well, that we took the square root of 9 and it became the 3. So that's why the whole root went away, because we took the square root of the number. The next one has a negative exponent. A negative exponent we're going to evaluate in the same way, but the first thing we're going to do is just put it all on the bottom of a fraction. A negative and an exponent just puts the whole thing onto the bottom of a fraction. Then we're going to evaluate the bottom part of this the same way as we did the last one. At the top is a power, so 32 squared. The bottom is a root, fifth root. Again, we can do either one of those first. We could square 32, but I don't know what 32 times 32 is. Or we could take the root first. A fifth root is asking, what do I multiply 5 times to get 32? Well, if I'm multiplying something 5 times, that's a whole lot. 32 is not that big of a number, so it's going to have to be something really small. So if we don't know, I would grab a calculator and check, is 2 times 2 times 2 times 2 times 2 32? And it is. Okay, I don't expect you to know all of your fifth roots by heart. You can check a calculator on that. If I multiply 5 2's together, it gives me 32. So the fifth root of 32 is 2. I haven't done anything with that squared yet, so that's just going to tag along. And now we can evaluate that. 2 squared is 4. So we get an answer of 1/4 then.
Which one's the power again?
The top is the power. Bottom is the root. Okay, so 16 to the 5 has. The top is the power. The bottom is the root. So we get the square root of 16 to the 5th. There's no way I know what 16 multiplied 5 times is, but the square root of 16 is 4. I don't even know what 4 multiplied 5 times is, but I could grab a calculator to work that out. And get 1024. This one has a negative exponent. A negative exponent is just going to put the whole thing onto the bottom of a fraction. Then we evaluate that fraction exponent the same way. Top is the power, so power of 2. Bottom is a root, so cube root. Cube root of 64. What times itself 3 times is 64? 4. And 4 squared is 16. So we get 1/16. Questions? Right, the next one says estimate on the calculator. There is a place on your calculator that you can find what's called an nth root, and it would allow you to enter any type of root in there. It's within menus and stuff like that, so what I do instead is I do this problem kind of backwards of what we did in the last problem, and turn this power and root into a fraction exponent. And then we can type that into the calculator without having to dig into any menus or anything. So we're going to go 5 to the power of. Now remember, top is power, bottom is root. So the top is the power of 3. The bottom of that exponent is going to be the root of 4. So this is the same thing as 5 to the 3/4. So we're kind of doing this like backwards that first type of problem. In the first type of problem, we were given the fraction exponent and we wanted to turn it into roots. Here we're given the roots and we want to turn it back into the fraction exponent. Top is power, bottom is root. Now we can type this into the calculator without having to dig into any menus or anything. We're going to go 5 to the power of, and then make sure you put parentheses around that exponent of 3/4. If you do not, what the calculator is going to do is do 5 to the power of 3 and then divide it by 4, which is not what we want it to do. Okay. So you need to make sure that you put parentheses around that exponent of 3/4. And since it says estimate, or the directions in the book might say approximate on the calculator, You can expect to have a decimal answer here and then just round it off to a few places. Questions on that? Okay, our last type of example is solving an equation. So to solve an equation, we always want to get our x part alone. So the first thing I need to do here is get rid of the 2. How do I get rid of the 2 on both sides? Divide by it. So I get x to the 4th is equal to 81. And then we undo a power with the opposite type of root. So if it's a 4th power, we're going to do that same type of root and do a 4th root. A 4th root undoes a 4th power. So then I get just x equals. Now, this is where those rules from the beginning of the notes come into play. We have to think about what kind of root are we taking. Are we taking an even root or are we taking an odd root? An even root, because we're doing a 4th root, and 4 is an even number. Okay, so if the type of root we are taking is an even number, your answer will require a plus minus. If the type of root you are taking is an odd root, you do not need that. Okay? It doesn't matter what the number underneath it is, it matters the type of the root. So this is a 4th root. 4th root needs the plus and minus. Okay? Even needs plus and minus, odd do not. Then, what times itself 4 times is 81? 3. So our answer is positive and negative 3.
How do you know, like
like
what problem to do, the plus and minus?
If you're solving for an x,
Oh, you said it was 3.
then you'll need to think about the plus and minus thing. If it's just a problem that says like evaluate, then you don't need to worry about pluses and minuses. But if there's an x you're solving for, then you have to think about the plus and minus. Alright, last example here. We are solving problems always from the outside in. We cannot get rid of that minus 2 because it's trapped inside of a group. Okay? So what we need to do is get rid of the outside stuff first. So how do I get rid of that 3rd power? We can't really distribute a power to each part. What we would have to do is write out like x minus 2 times x minus 2 times x minus 2 and distribute all of that. That's going to get really messy. So there's a quicker way to just get rid of a 3rd power.
Do the opposite.
Do the opposite, which would be a 3rd root. So we're going to do the 3rd root of the whole thing. So a 3rd root of a 3rd power will cancel and leave us with just an x minus 2. I don't even really need the parentheses anymore. Equals. Now what kind of root were we taking? Odd or even? Odd. So we do not need plus and minus here. Cubed root of 10 is not a pretty number, so it's just going to stay cubed root of 10. Okay, there's no nice thing that I can multiply 3 times and get 10. We still want to get x alone, so now what do we need to do to get x alone? Add 2. We did stuff similar to this when we worked on solving quadratic equations, and we learned we do not add that 2 to the stuff inside of the root. So it's just going to be 2 plus 3 square root of 10. When we were doing quadratics, we always had a plus or minus in there because we were taking a square root, which was an even root. This problem's taking a cube root, which is an odd root, so we don't need the plus and minus. We just need the plus. Okay? Your homework tonight is from 7-1. It's a pretty short assignment to get us back into things.